Today we are going to start chapter number 15, multiple integrals of the book of Calculus by Thomas. This chapter is core part of each discipline in engineering, BS Computer Science, BS Physics, BS Chemistry, BS Statistics and BS Mathematics. In this chapter, we will learn multiple integrals. Topic of multiple integrals is always a problem for the students, especially while solving multiple integrals. How to take limits of the integration is a problem. We shall discuss this chapter in detail and we shall discuss such techniques that taking limits of the integration will never be difficult for you. In today's lecture, we shall define definite partial integrals. We shall define what are iterated integrals. We shall solve question number 1 and 3 of exercise 15.1. After studying these definitions and after solving these questions, you will be able to solve question number 1 to 14 of exercise 15.1. In today's lecture, we are not going to define what is a multiple integral. We are starting with easy topics. After this lecture, in the second lecture, we will take the first main difficult definition of the multiple integral and we shall define how the iterated integrals are related with multiple integrals. Let us start today's lecture. First of all, in today's lecture, we are going to define iterated integrals over rectangles. What do I mean by over rectangles and what is meant by iterated integral? Let's start with some notations. We shall denote the set of real numbers by this double R, and by R we means a subset of R square, and we will call a subset of R square a region. What kind of region we are going to consider today? We are going to consider rectangular regions. Let's say R is a region in R square. R is a subset of R square. R square mean plane, mean xy plane. If we have a set in xy plane, then that set we will denote by R and we will call it a region. We are going to discuss iterated integrals, partial definite integrals over the rectangular regions. If we have a function f from the region R to the set of real numbers, we shall discuss the iterated integrals and definite partial integrals for the function f. We have a region R in R square. We have a function f from the region R to the set of real numbers, and we are going to discuss specially the rectangular region. What is meant by rectangular region? If the points of the region xy satisfy these two conditions, that x between a and b including a and b and y between two numbers c and d including c and d, then the region R is a rectangle. The shape of the region actually will be a rectangle. If we have values of x between a and b and values of y between c and d, then the ordered pairs xy will be part of this rectangle. Whenever we take a region R such that each point in the region R satisfy these two conditions, then the region R is a rectangle. In today's lecture, our first definition is partial definite integral with respect to x. The partial definite integral with respect to x of the function f over the rectangular region R is denoted as the integral a to b of the function f of x y dx. It is an integral in one variable. The function is although of two variables, but in this integral we will integrate the integral with respect to x and we will keep y constant. This integral is called partial definite integral with respect to x. If we have to solve this partial definite integral with respect to x, the method will be that we shall keep y constant, we shall keep y fixed, and we shall perform ordinary integration with respect to x. As we are keeping y fixed, y constant, so we are denoted this integral as partial definite integral. How we shall do this integration? Let's see in an example. The example is evaluate the partial definite integral with respect to x, integral from 0 to 1 x y square dx. Why it is partial? Because the function which we are going to integrate is of two variables x and y, but we are going to integrate only with respect to one of these variables, and here the variable of integration is x. So let's integrate this partial definite integral with respect to x. In order to integrate this integral with respect to x, what I have told you that keep y constant, keep y fixed. If we keep y fixed, y constant, we can take y square outside the integral and we have to integrate 0 to 1 x dx with respect to the variable x. Now it is question of ordinary integration, and you remember very well all the formulae of the ordinary integration. If you do not remember those formulae before studying this course, I suggest you to memorize all the integral formulae. In this question, now we have to integrate x, and if you remember, the formula for the integral of x power n is increase the power by 1 and divide by the resulting power. If we use this formula and evaluate this integral, the answer will be x square over 2 and the limits will be 0 to 1. And how we shall solve these limits? Replace the variable x by the upper limit minus replace the variable x by the lower limit. This y square is outside, so keep it as constant y square, replace x by the upper limit 1, so 1 square by 2, that is 1 by 2, and minus replace x by 0 minus 0, and 1 by 2 minus 0 will be 1 by 2. The answer is y square over 2. This we have evaluated the partial definite integral with respect to x. Notable point is that when we have evaluated the partial definite integral with respect to x, the final answer contains the variable y. Remember that the partial definite integral with respect to x is a function of variable y. I shall use this note on the next slide. On this slide, we have defined partial definite integral with respect to x, and we have evaluated a partial definite integral with respect to x. On the same lines, you may guess that I am going to define partial definite integral with respect to y. So let us define partial definite integral with respect to y. Before defining partial definite integral with respect to y, the basics are the same. We have a function f from a region R to the set of real numbers R. Our region R is a rectangular region, and what is the partial definite integral with respect to y? The partial definite integral with respect to y is written as integral f of xy from c to d dy. This integral is called partial definite integral with respect to y. How we shall evaluate this integral? To evaluate this integral, keep x constant and integrate with respect to y as an ordinary integral, and then use the limits of the integration. Let's solve an example. Evaluate the integral 0 to y xy square dy. Here this integral is a partial definite integral with respect to y. We have to perform integration with respect to y, and when we have to integrate with respect to y, we shall keep x constant. If we keep x constant and we integrate y square, how will we find the integral of y square? Very simple. The power rule. If we have integral y power n and we have to integrate it with respect to the variable y, the answer is quite easy. Increase the power by 1 and divide by the resulting power. And if we are finding indefinite integral, there will be a constant of integration c, and in case of definite integral, we shall apply the limits. Here in this integral, x is constant and we have to integrate y square, increase the power 2 by 1, so new power of y is 3, and divide by the new power 3, so the integral is y cube by 3, and the limits of integration we have written on the right hand side 0 to 1. And how we shall apply these limits? Replace by the upper limit 1, so we have 1 by 3, 1's cube is 1, so 1 by 3, minus replace y by the lower limit 0, so it is 0, and the answer is x by 3. As we have noted in the previous case, here is also a point to note that when you evaluate the definite integral with respect to y, the answer will be a function of x. The partial definite integral y is a function of x. The partial definite integral with respect to x was a function of y, and the partial definite integral with respect to y is a function of x. If we have a function of x, we can integrate it with respect to the variable x. And if we evaluate partial definite integral with respect to x, the answer will be a function of y, and we can integrate this function of y with respect to y. This answer is a function of x and can be integrated with respect to x. The answer of this partial definite integral is a function of y, and this function of y can be integrated with respect to y. If we evaluate this answer with respect to x and this answer with respect to y, the resulting integrals are called the iterated integrals. Let's define the iterated integral. When we integrate this function of y with respect to y, we get this double integral expression, and this is called iterated integral. How we shall solve this iterated integral? Quite obvious. First integrate with respect to x, and then the resulting answer is integrated with respect to y. On the same lines, the second iterated integral is written as this integral integrated with respect to x. The answer of this integral is a function of x, and when we integrate this answer with respect to x, this resulting expression is also called iterated integral. How these iterated integrals are solved? The first iterated integral is solved. First solve the inner partial definite integral with respect to x, and then integrate the answer with respect to y. And in order to solve this iterated integral, first solve the inner integral with respect to y. This will be a function of x, and then evaluate this integral with respect to x. Let's see the evaluation of these iterated integrals on next slide. First, we are going to learn method to evaluate the iterated integral. Here, the region of integration, the domain of the function f of xy is the rectangular region. In today's lecture, we are defining iterated integral when the domain of the function f is a rectangular region. In general cases, when the domain is a general domain, not specifically a rectangular region, how the iterated integrals are solved, we shall discuss in future lectures. Also, how these iterated integrals are related with double integrals, with multiple integrals, and how we define multiple integrals. These are the coming topics. So, first, how to evaluate this iterated integral. The step 1 is evaluate the inner integral c to d f of xy dy with respect to y by holding x fixed, and then evaluate the integral a to b with respect to x. Let's see this evaluation in a question. Exercise 15.1, question number 1. Evaluate this iterated integral. The inner integral is partial definite integral with respect to y, and then outer integral is to integrate with respect to x. First of all, I am going to sketch the region of integration. The limits of integration with respect to y are from 0 to 4, and limits of integration when we will integrate with respect to x are from 1 to 2. As the limits of integration are constant numbers, so the domain of the function to xy, which we are going to integrate, is a rectangular region. The sketch of this rectangle is here shown in this diagram. The limits of the variable x are from 1 to 2, and the limits of the variable y are from 0 to 4, and this rectangular region is the domain of the function over which we have to evaluate this iterated integral. Let's start the solution. First, we have to integrate with respect to y. The outer integral 1 to 2 dx will remain same. In order to evaluate this inner integral, we shall keep 2x constant and we shall integrate with respect to y. How we shall integrate with respect to y? We have used this formula before in 2 questions. Raise the power of y by 1 and divide by the resulting power. So 2x is constant and the integral of y is y square by 2, and limits of the integration are 0 to 4. Before integrating this answer with respect to x, we shall evaluate the limits. When we shall replace y by 4, the 4 square will be 16, and in the denominator this 2 is cancelled by this 2, x is outside this bracket. When y is replaced by 0, 0 square is 0, and now we have to integrate this in 16x with respect to x. In order to evaluate this integral, 16 is a constant number, take it outside the integral and integrate x by same using the power rule. Increase the power of x by 1, so the new power is 2, and divide by the new power, and the limits of integration are 1 to 2. Now we shall evaluate these limits of integration. When x is replaced by 2, square of 2 is 4, 4 by 2, and when x is replaced by 1, 1 square is 1, so 1 by 2. When 1 by 2 is subtracted from 4 by 2, the answer is 3 by 2, and on multiplication we get 24. This we have evaluated the iterated integral, in which the inner integral is the partial definite integral with respect to y, and outer integral is to integrate with respect to x. What I am going to do next? Guess it. Your guess is right. I am going to tell you the method how to evaluate the iterated integral, in which the inner integral is partial definite integral with respect to x and the outer integral is to integrate with respect to y. So method to evaluate this partial definite integral. Remember that this iterated integral is defined for a function f over the region R when region R is a rectangle. In order to evaluate this iterated integral, first we shall evaluate the inner partial definite integral with respect to x. After evaluating this integral, we shall get a function of y and then evaluate this integral with respect to y. Finally, we will get a number. Let's practice this in an example. Exercise 15.1 and question number 3. We have to evaluate this iterated integral, in which the inner integral is the partial definite integral with respect to x and the limits of integration with respect to x are from -1 to 1, and the outer integral is to integrate with respect to y with the limits of y -1 to 0. Although the sketch of the region of integration is not required, but in case of integrals, when the region of integration is a general region, the sketch of the region is very necessary. Therefore, I am also going to sketch this region of integration. In this integral, the limits of integration with respect to x are from -1 to 1 and with respect to y are from -1 to 0. So this shaded region is the region of integration. On this domain, we have to evaluate the iterated integral of this function x plus y plus 1. The process of integration is quite easy. Let's evaluate this iterated integral. In order to evaluate this iterated integral, the outer integral -1 to 0 dy will be same, and first we shall evaluate the inner integral. In first term, the integral of x by power rule is x square by 2. In second term, y is constant and we have to take integral of 1 with respect to x. The integral of 1 with respect to x will be x. In the third term, the integral of 1 will be x, and the limits of integration are from -1 to 1. Before integrating it with respect to y, we shall solve these limits of integration. -1 to 0 dy, this integral is same, we have to solve. First replace x by the upper limit 1, so 1 by 2 plus y plus 1 minus replace x by the lower limit -1, square of -1 will be 1, so it will be 1 by 2. Here when x is replaced by -1, it is -y, and here when x is replaced by -1, it is -1. And before integrating with respect to y, we shall simplify these terms. This 1 by 2 positive and 1 by 2 negative will be cancelled out. This minus will become plus, and y plus y will become 2y, and this 1 and this minus plus 1 will become 2. So the integral inside is 2y plus 2, and taking 2 common from the integral, the remaining integral is now from -1 to 0 y plus 1 dy. Now we shall evaluate this integral with respect to y. The integral of y will be y square by 2, and the integral of 1 with respect to y will be y. The limits of integration are from -1 to 0. Replace y by the upper limit 0. We have 0 plus 0 and then minus of the formula, and replace y by the lower limit -1. -1 square is 1, so it is 1 by 2 and -1. This 1 by 2 minus 1 will become -1 by 2, and this outer minus will become plus, and 2 is cancelled by 2, so the answer is 1, and the answer of this iterated integral is 1. In today's lecture, we have defined partial definite integrals and iterated integrals, and we have solved 2 questions from the exercise 15.1. After learning these definitions, after learning techniques of solving iterated integrals, you can solve question 1 to 14 of exercise 15.1, the book of calculus by Thomas. If you feel problem in any question, our WhatsApp number is given in the description and also is on the screen. You can message your solutions on our WhatsApp number. We shall guide you. For today, it is enough. The main definition, what is a double integral and how double integral is related with iterated integral, will be discussed in next coming lecture.